Okay, so let's say we have this image over here, right, which is X. Okay, we have X over here. Now we want to be able to determine this X. Okay, if we build our neural network, we want to be able to detect this X. So the image contains X, which of course it has to be in a form of a matrix, right? That is what the computer is going to see. So this X image, where we have indicated a certain number to it. So wherever the X character appears, we have indicated the place as 1. If the X character is not appearing there, it's -1. Okay, so you can see the black background is all indicated as -1, -1, -1. And then the X is indicated as 1, right? The same thing with this X over here, right? Where the X appears, you see that we have 1 over there, but where the X is not appearing, we have -1. So we want to see, I mean, for humans, as soon as we see this, we know that this X equals this X. It doesn't matter the shape. We know that the X is equal to X. Most of the time, the way people write their letters are different. Okay, so maybe this one is a perfect X, which mostly happens when you type the X, right? But when you're doing handwriting, the X might be something like this. Okay, some shady kind of X like this, right? But I mean, for human intuition, we know that this X is the same as this X. But will the computer be able to identify that? Okay, and we want to empower the computer to be able to identify this X as this X. Okay, regardless of the shape, whether it's shrunk or rotated or deformed or whatever it is, we want to still make sure that our computer is able to detect this X and then detect this X as the same X. Okay, so let's see how this thing is done. Right now, what we're going to do is that, what if the computer can now detect patches of it? Okay, patches of the X. Instead of letting the computer get confused whether this one is equal to this, right? We want it to now detect patches of the X. Okay, so it can say that, okay, I'm going to detect the left top corner of whatever image that you have. So if I take this image, I will detect the left top corner of it. And when I take this image, I also determine the left corner of it. Then I realize that I have 2 of the white that are stacked adjacent to each other like that. Okay, which is the same here, so I can equate them. Okay, if I take, say, the middle over here, right, I can see that they all have 1 white box here and then 2 white boxes on top, 2 white boxes down here, right, which happens over here. So I can equate them, right? If I take, say, this one, which is on the bottom left corner, right, I can see that they are 2 whites which are stacked on top of each other like that. Okay, adjacent on top like that, and I can also equate them. Okay, so we want the computer to determine patches of it like this, instead of just feeding the entire image like this, and then the computer will get confused whether this is equal to this one, right? But if it's able to detect patches of it, it will be able to detect that this X is the same as this X, right? And by doing so, we also get rid of a lot of noise. For instance, in the normal neural network, we would have fed the entire image to the neural network. Okay, so all these background that are unnecessary will also be determined, because all these are also pixels over there. Okay, they are all pixels. But in this case, if we are going to detect these things, then we will we ignore the background, which is not of importance to us. Okay, we'll be able to ignore all that pixels. Okay, so imagine the number of pixels we are ignoring over here. Okay, the number of pixels that we will ignore. Right, the same thing with this one, right? So we save a lot of memory over there, because if we feed the entire thing, it's just a waste of resources over there. Okay, so that's what we want to actually do right now. Once we do that, what we do next is define our filter, which we will put on top of the entire image to extract the various components of the image. Okay, the various patches of the image. So let's say we define a filter like this, right, where we have 1, 1, 1, and then -1, -1, -1, -1, -1, -1. So this is a 3x3 is a 3x3 filter. Okay, a 3x3 filter over here, right? So once we do that, now we can put this filter on top of this patch over here. Okay, on top of this patch over here, right? And you can see that once we do that, it will be able to fetch the part that is important. For instance, here is 1, right? Here is 1, 1, 1. So it will be able to detect these ones, right? And then ignore these ones, right? The negative ones are going to fall on this part. It's going to ignore that part. The same thing with the middle one, right? Now, if we put it over here, if we put the same filter here, right, on the middle here, right? If we put it in the middle here, Okay, what is going to happen is that it's only going to highlight the part that is going to meet. Okay, so for instance, here will be marked as 1, 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 right? And the middle as well, but here will be negative, here will be negative, here will be negative, just like you're seeing over here, right? So this filter is on top of here. Okay, we are putting this filter on top of this patch over here, right? And we'll be able to extract only the parts that are important, and the ones that are not important are going to be negative, right? Going to be marked as negative, right? Going to be marked as negative like that. Okay, and we'll do the same thing for this one where we place it over here, right? Let me change this one to something like this. Okay, where we place the filter somewhere here. Okay, we place the filter somewhere here. Right, and if we do that, you see that it's only the middle ones that are going to be 1 1 1. The rest are going to be negative, right? Only this one is going to be 1 1 1. All here is going to be -1. Here is going to be -1 -1 -1 -1 -1. Okay, like that. Now we need to find a way to do this kind of operation. Okay, because we need to now link or connect this filter with the image that is here. Okay, we need to find a way to connect them because this is a filter that we have defined, and the image too is going to be converted to a matrix like this. So we need to find a way to connect the two. Okay, we need to find a way to connect the two. All right, and that's when we need to do the convolution. Right, that's when we need to do the convolution operation. Right, convolution operation, which is nothing but the element-wise, right? Element-wise multiplication or operation. Let me just use it like that. Element-wise operation. So whatever pixel value that is there, we multiply it with the respective kernel value over there. Okay, whatever pixel value is there, we multiply it with the respective filter value or kernel value over there. Okay, let's see how we do that. All right, let's see how we actually do that practically.